All right, let's do some solutions for our practice exam. Given that the sine of theta is 2/5, theta is in the second quadrant, complete the chart. Well, the sine of theta is 2/5, so we're going to go ahead and put that in there. That also means that the cosecant of theta is 1 over that, or 5 over 2. Now we remember our fundamental Pythagorean identity, sine squared theta plus cos squared theta equals 1. Since the sine of theta is 2/5, sine squared theta is 4 over 25, plus cos squared theta is equal to 1. That makes the cos squared of theta 1 minus 4 over 25. 1 is 25 over 25. This gives us 21 over 25, which means the cosine of theta is plus or minus the square root of 21 over 25, so root 21 over 5. And since we are in the second quadrant, that means cosine of theta is negative. So the cosine of theta is minus root 21 over 5. We can reciprocate that for secant, for minus 5 over root 21. Remember, I don't care about simplifying radicals in the denominator. Now, tan of theta is simply sine theta over cos theta. Since the sine of theta is 2/5 and cos theta is minus root 21 over 5, the denominators of 5 cancel, giving us minus 2 over root 21. Cotan is 1 over that, minus root 21 over 5. That's it. Very similar, given that secant of theta is minus 5, go ahead and fill that in. Minus 5, which means cosine is 1 over that, or minus 1 over 5. We can now find all the rest. So we can use the same identity we used last time, sine squared theta plus cos squared theta equals 1. But since we were originally given secant theta, let's just go ahead and use the identity. Tan squared theta plus 1 is equal to secant squared theta. Since secant theta is minus 5, the square of that is 25. So tan squared theta plus 1 equals 25. Tan squared theta equals 24. Therefore, tan theta is plus or minus root 24. I can factor a little bit out of that and call that plus or minus 2 root 6. Tangent of theta is negative, so I'm going to go ahead and select minus 2 root 6. Cotan is 1 over that. Therefore, that is minus 1 over 2 root 6. Okay, now as far as sine and cosecant, we could use a Pythagorean identity, or we could simply say tan theta is sine theta over cos theta. In other words, multiplying both sides by cosine gives us sine theta is tan theta times cos theta. We know tan theta is minus 2 root 6. We know that cos theta is minus 1 over 5. This gives us sine of theta is 2 root 6 over 5. So 2 root 6 over 5. Cosecant is 1 over that, so I just reciprocate it for 5 over 2 root 6. Cos theta is 1/2. All right. We could actually find the angle theta from the information given, but that's not asked. I'm just going to go ahead and use sine squared theta plus cos squared theta is equal to 1/2. Since cosine is 1/2, this gives us sine squared theta plus 1/4 is equal to 1/2. Subtracting a fourth from both sides gives us sine squared theta is equal to 1/4, or sine theta is plus or minus 1/2. Since cosecant theta is positive, that's 1 over sine, therefore sine is also positive. So sine theta is 1/2, cos theta was given to be 1/2. This means that cosecant and secant are the reciprocals, which are 2 and 2 respectively. Tangent is sine theta over cos theta. Since sine theta and cos theta are equal to each other, sine theta over cos theta is 1, and cotan, 1 over 1, is also 1. Okay, tan theta is root e plus 1. Let's remember our identity, tan squared theta plus 1 is equal to secant squared theta. Since tan theta is the square root of e plus 1, tan squared is just e plus 1 equals secant squared theta. This gives us that secant theta is plus or minus the square root of e plus 2. Since secant theta was given to be negative, I'm going to go ahead and select minus the square root of e plus 2. Okay, since tangent was root e plus 1, cotan is 1 over that. Since secant was minus root e plus 2, cosine is 1 over that. Now, as far as sine and cosecant, we could use an identity, or we could simply remember something like tan theta is equal to sine theta over cos theta. Since tan theta is root e plus 1, that's going to be sine theta over minus 1 over root e plus 2. So I'm just going to multiply that to the other side and get that sine theta is minus the square root of e plus 1 over e plus 2. So minus root e plus 1 over e plus 2. That's all under the radical. Cosecant is just the reciprocal of that. So minus root e plus 2 over e plus 1. So parentheses for clarity. Okay, we've got a function here. It's a sine. We're supposed to draw one full period. It's a sine function with a positive coefficient, so our basic shape is this right there. The median is 18. The amplitude is the absolute value of 3, which is 3. The period is 2 pi over the coefficient of theta inside the sine, which is 5. There's no good way to simplify that, so 2 pi over 5. This problem does not have any phase shift. The phase shift would be something being added or subtracted inside the sine function, so a phase shift of 0. Now if the period is 2 pi over 5, by multiplying both sides by a quarter, we get that a quarter of the period is 2 pi over 20, or just pi over 10. So now we can start labeling points on our little picture. There was no phase shift, so we're going to start at 0. And we start for a sine curve at the median, which was 18. I then move forward a quarter period, so pi over 10, and I go up an amplitude, so that's up to 21. Now I'm back down to a median height of 18. As far as our theta coordinate, we go forward 2 quarter periods, which we could simplify to pi over 5, but I don't really care. Next, we go forward another pi over 10, so now we're at 3 pi over 10, and from the median of 18, we go down an amplitude to 15. Then finally, we go forward a complete period, which we already know is 2 pi over 5, and we're back at the median. There we have it. Okay, we have a cosine function with a negative coefficient, so we're going to start at our minimum and go from there. All right, we need to label the minimum, the median, the maximum, the median, the minimum. Okay, our median value is right here of minus 1. The amplitude is the absolute value of minus 1/8, or just 1/8. The period is 2 pi over whatever is multiplying theta. So that's going to be 2 pi over 3 pi, or just 2 over 3. So the period is 2/3. The phase shift is whatever is being subtracted from theta inside the cosine function. And I believe that this may be written differently than how it was in the practice exam itself. I may have a typo here. So in the practice exam, I think it was written like this. So here's a slight difference. I'm going to do it as written, and then I'll indicate how it would be done for the way it was written on the practice exam. So here we are simply adding a 2 there, which means that we have a minus 2. So the phase shift is minus 2 over the multiplier of theta, which was 3 pi. So that's just minus 2 over 3 pi. This tells me to start this curve at minus 2 over 3 pi, comma, the minimum value. Now the minimum value is going to be a median, which was minus 1. Then we need to take away an amplitude, or subtract an eighth. And negative 1 minus 1/8 is negative 9 over 8. Next, I'm going to go forward by 1 quarter period. So if a period is 2/3, then a quarter period is 2 pi times a quarter, which is just going to work out to 1/6. So from minus 2 over 3 pi, I simply go forward 1/6, and now I'm at the median height of minus 1. Then from minus 2 over, over 3 pi, I go forward 2 quarter periods, and now I'm at the maximum, which is a median of negative 1 plus an amplitude, or minus 7 over 8. Now from minus 2 over 3 pi, I move forward 3 quarter periods, or 3/6. I'm back at the median of minus 1. Then from minus 2 over 3 pi, I go ahead and I move forward by a complete period, which was 2/3, and I'm back at the minimum value we've already computed to be negative 9 over 8. So the only thing that changes in how I believe it was written on the exam, where there was a parenthesis around theta plus 2, That just means that inside the cosine function, what we have is 3 pi theta plus 6 pi by distributing this out, in which case our phase shift, or phi, is going to be negative 6 pi. Sorry, so phi is negative 6 pi here, which means our phase shift is going to be negative 6 pi over 3 pi, or just negative 1/2. Pretty sure that's how it was written on the exam. It was supposed to be a little cleaner than this business here of negative 2 over 3 pi. All right, now we have a picture of a graph, and we're supposed to figure everything else out. So we appear to have a positive sine shape. Okay, sine curves start at their median, so that's 3, because we see that it starts at a height of 3. Also, there is no phase shift. Our positive sine shape is starting at an input of 0, so there's no phase shift. Okay, next we need to determine our amplitude and our period. Well, from the median height of 3, our maximum is 6, so it went up by 3, so our amplitude is 3. So we have a 3 sine of something. Now what we have to do is figure out the period. So from here to here, in our input, we went from 0 to 2. So this is a distance of 2, but that is a quarter of the period. So if I multiply both sides by 4, we get that the period is 8. Inside the parentheses of the sine function, we have our omega times theta, where 2 pi over omega is equal to the period. We just determined that the period is 8. Okay, I can reciprocate both sides and multiply by 2 pi to get omega is equal to 2 pi over 8, or pi over 4. So we have pi over 4 times theta there. And another one just like the last one. So we have some sort of negative cosine curve. Okay, we just need to determine the median, period, amplitude, phase shift, etc. So let's go ahead and take a look. We have a maximum height of -5 and a minimum of -10. The median is the average of those. So the median is the max plus the min over 2. -5 minus 10 over 2. -15 over 2. So there is our median, -15 over 2, which ends up being subtracted from the cosine function right there. Okay, so our median height, we don't have to label the points on this graph. I'm just labeling that the median is at -15 over 2. Now, in terms of the amplitude, we need to determine the distance from the maximum to the median, or the median to the minimum, either way. So the amplitude is the distance between -5 and 15 over 2. So I compute the distance, or the difference, -5 minus -15 over 2. That's -5 plus 15 over 2, which just works out to be exactly, let's make that a little cleaner, -10 over 2 plus 15 over 2, or just 5/2. So our amplitude is 5/2, so I put that here. Okay. Now, as far as our period goes, let's look at our picture. Here the input is 3 pi, and here the input is 9 pi. So from 3 pi to 9 pi, that distance is 6 pi. But that's not a full period, that's a half of the period. Multiply both sides by 2, and we get that our period is 12 pi. But the period of 12 pi is 2 pi over omega, the multiplier on theta. Okay, so reciprocate both sides and multiply by 2 pi, and you'll get that omega is equal to 2 pi over 12 pi. Pi's cancel, 2 over 12 is 1/6. So I have a 1/6 theta here. Okay, now let's determine our phase shift. Now we elected to make this a negative cosine function because that was the shape we saw, which means we need to determine where it starts here. But observe, this went from 3 pi to 9 pi for a distance of 6 pi, so it's another 6 pi to get back here. So 3 pi minus 6 pi tells me that the coordinates here are -3 pi, comma, it is the minimum of -10, but I don't really care. So our phase shift is 3 pi units to the left. so minus 3 pi. Now our phase shift, let's look for some blank space. I'll just put it right here under where the words phase shift are. We're looking for our phase shift of minus 3 pi is going to be phi over omega. Omega was 1/6, so I multiply that to the other side, and we get negative 3 pi times omega is equal to phi. So negative 3 pi times 1/6 is equal to phi, or phi is equal to minus pi over 2. And remember that in our expression, which I'm just going to put a box around to sort of isolate it from all the work, phi is typically subtracted. So we have a minus pi over 2, so plus pi over 2. Okay, so there it is.